Property of Fourier transform, multiplication of signals. This property states that Fourier transform of the product of two signals in time domain is a convolution of their two Fourier transforms. Let us consider two signals x1 of t, x2 of t, and their Fourier transforms are capital X1 of omega and capital X2 of omega. Now, a Fourier transform of x1 of t into x2 of t is 1 by 2 pi into convolution of x1 of omega and x2 of omega. This can also be written as 1 by 2 pi into integral minus infinity to infinity capital X of u into capital X2 of omega minus u into du. Proof: Fourier transform of x1 of t into x2 of t. From the definition of Fourier transform, this can be written as integral minus infinity to plus infinity x1 of t into x2 of t into e power minus j omega t into dt. Now write x1 of t as inverse Fourier transform. The expression is integral minus infinity to infinity 1 by 2 pi into integral minus infinity to plus infinity x1 of a into e power minus j omega t into dA into x2 of t into e power minus j omega t into dt. So this can be rearranged as 1 by 2 pi into integral minus infinity to plus infinity capital X1 of a into integral minus infinity to infinity x2 of t into e power minus j into omega minus a into t into dt dA. The underlined part can be written as x2 of omega minus a from the definition of Fourier transform. That implies 1 by 2 pi into integral minus infinity to infinity x1 of a into x2 of omega minus a into dA. This can be written as 1 by 2 pi into convolution of capital X1 of omega and capital X2 of omega. Therefore, Fourier transform of x1 of t into x2 of t is 1 by 2 pi of convolution of capital X1 of omega and capital X2 of omega.